So the topic for this week is linked list. And so far, actually, we have studied the arrays, right? We know what is arrays. Then we also know kind of list. List is it's a kind of it's a form of array. And whenever you have a collection, I mean, in general, you can call it a collection. Whenever you have a collection of elements, then you talk about the array. Now, the main advantage of using array is the following. Whenever you have an array, let's say you have an array X and it has 5 elements, and you can define it like 1, 2, 3, 4, 5. So if you can define an array, the main feature of an array is that you can access any element inside the array if you know the index number, meaning their position in the array. So the position scheme starts with 0. So you have 0, 1, 2, 3, 4. These are the 5 places. So if you say x0, then you talk about 1 in the above array. If you write, let's say, x3, then you talk about 4 in the above array and so on. So you can see the advantage of the array is that if you know the index, you can find the element. Now, the point is what happens if you want to insert something into the array? It is possible, like you can insert an element next to element 2. Let us say we want to insert it here. Then you know what is going to happen after 3, we have to add a new define, basically a new element, but then we have to reorganize the indexes. You have to expand the size of the array and reorganize the elements like 4, 5, etc. So insertion is costly because you have to, in principle, what's possible scenario, you have to shuffle each of the indexes. And if you want to delete something from the array, the same story. Now, there are other interfaces we learned, like, the queue. I mean, it's there in the STL. We did not practice it, but the queue is basically first in, first out type of organization, type of collection. Example is the line of vehicles in the toll booth. So the vehicles enter the toll booth, each of them enter the toll booth. Whoever comes first get to go first. They go to the toll booth, they collect the ticket or pay for their tolls, and then they go out. So first in, first out. You could have a collection called stack. You know, stack is little tricky, but it's very simple in understanding if you understand it. So it's like you have a stack of book. So you put the books together. Whatever you put in the last, whatever you put last onto the stack, you can pick that up first, because you cannot just penetrate through the books to find out the whatever book is there. Now, this type of collection is called last in and first out. But today we are going to understand a very specific type of collection, which is called linked list. That means, the list by definition, list is a collection of element like this one. You have multiple element in these boxes, and this is a list of elements. So such a link is it can be represented by arrays, any kind of collection. But linked list has a special property is that every element is connected with their next element, or there is a connection between every element and the next element. That is called the unidirectional linked list or single linked list. That means you have multiple elements, this one, two, three, four, and so on. So one is one is connected to two, two is connected to three, three is connected to four, and so on, so on, so on. Sometimes linked list also can be double, can have double connections. Like number one does not have any previous connectivity. There is nothing behind one, but two has a pointer to one, three has a pointer to two. So every node has a next, every element of the linked list has next pointer and previous pointer for a doubly linked list. You know, the linked list, where do we use the linked list? That is another example. I mean, there can be multiple usage of the linked list, but I want to give you very modern example. That is, if you have heard about cryptocurrency, that is built on a data structure called blockchain. Now, the blockchain, whenever you talk about the blockchain, it is a form of a linked list. Every block is connected to every other block. Now, when you in the nomenclature of cryptocurrency, when you talk about blockchain, the famous question is what is block and what is chain? So block is the element. You can say one to be the block. I mean, it is not just a numerical, but it can be an object, very complex object, whatever, however complex you want to call it. It doesn't matter. And the chain is the link. So that is your linked list. The linked list is essentially uh, it essentially consists of multiple elements in a collection where each element is connected to its next element for a singly linked list, or every element is connected to its previous as well as next elements for a doubly linked list. So that's called linked list in a very simple description. So if the question is what is a linked list, it's a collection first of all, and then the collection has the special property that every element has a pointer, or every element is linked with the next element for a singly linked list, and every element is linked with next and previous element for a doubly linked list. So the main advantage of linked list is that, I mean, you can through the pointers you can find the you can insert elements in between the list very fast. It's very easy to find out the pointer, I mean find out the position where you want to insert something, and then it's a matter of adding two pointers to it, previous and next, uh, in order to finalize the linked list. You don't have to go through the remaining objects in order to reorganize or reshuffling like we did for the arrays. So it's not an array, but if you were given an array, it is easy for you to build a linked list out of that array. I mean, every problem in the array interface can be, I mean, in the collection interface or in the collection world, you can start with a simple representation of an array, like your simple array, the array of multiple elements, and then you can you can establish the appropriate um, like add-ons. Like in the linked list you have the pointers for each element in order to establish a definitive data structure. In our case it can be a linked list. So, um, I mean, if you are given an array, you can build in principle a linked list, and most of our problems that we can solve using the linked list, it is those are like that. They are to begin with, they are all arrays. They can be all organized in the arrays, but we use linked list because of the ease of operation. Your data structure is uh, so easy here in case of linked list that your algorithms for doing insertion or deletion or update, those are really simple. You don't have to go through every element of the linked list um, to I mean after the insertion or deletion of a particular node to reshuffle them, to reset them iteratively. You can just do it in a very simple way. So that's about the linked list. That's the intro to the linked list. Now, that's what we were talking about, but here we can extend our understanding a little bit. So we were talking about 1, 2, 3, 4, those numbers, right? So the heart of the linked list is not the number or not the string or not any primitive data type. The heart of a linked list is a node. What is a node? Node is an object. So node is nothing but an object. And how do you define the object? That is that is basically required by what do you want in the linked list. Let's say your list has a number. So it is the number, let's say 1. But then in addition to the number, it must have at least one other element, which is a pointer. So you can have a pointer to the next node. So you can call it the next. So linked list is a node. I mean, the heart, the unit of a linked list is a node. The node has some data. So that's what one stands for. The node has a data and it also contains a pointer which is pointed to the next node or sometimes the previous node along with the next node. So that's a doubly linked versus singly linked list. So one data and at least one pointer. That is the constituents of that is the yeah constituents of nodes. Each node, and then linked list is a collection of those nodes linked to each other. So that's pretty much the way we can design a linked list. The nodes, when you talk about the nodes, you can think about the blocks in the blockchain, like blockchain framework. Each block is a node, and then in each block you have a lot of things like you have I mean, they are like banks, for in the concept of the cryptocurrency. You can have the data, like some shared data. Each block has set of complex objects related to the problem you are solving. Now, the main advantage of linked list is that the communication is so simple because in order to make the communication alive, to keep it alive, all you need to do is to maintain the connection with your next node. If you are dealing with a single linked list, you don't worry about the rest of the thing. You just worry about your next one that you are linked with. So that's the same thing for the blockchain. It is exchange of information. Once the information is there, all that same information is spread over all the blocks in the system. So uh, there is very, very little chance of manipulation, any malpractice, because you can modify one node, but your data is essentially encrypted and saved in every other node. So there is no way your data can be manipulated or uh, compromised. So, I mean, that's a different topic. I mean, how to solve those problems with the blockchain, but it comes with the discussion of the linked list. So, the data structure is similar, but there are a lot more thing in the blockchain than the linked list. But you can begin your thought process of the blockchain with the linked list, and then you can expand your, I mean, you can expand your studies and get more knowledge. So, the references. you can have the references, these pointers. They can be addresses, I mean, like address to the next block, next element, the memory address, or it can be just array index, right? I mean, each array, if it is an array, then each element is referenced by, each element is represented by the index 0, 1, 2, 3, 4, and so on. So your pointers may be simple memory pointer, or it can be just the indexes. Now, this data structure can be added to or removed from um, linked list during the execution. So you can modify the data structure, but that's a different story. We will address it later. So this is a very famous question. What is the difference between linked list, arrays, and vectors? Now, linked list can expand or compress as required. Arrays cannot, arrays have fixed size, but vector also can grow or shrink as needed. The the list can insert a node between other nodes pretty easily, but the other data structures cannot do that because for obvious reason they have to reshuffle their pointers, I mean their indexes. But in linked list, so if you have just a pointer, then you just point to the next node. That's it. You don't do anything else. It will not affect any other node. It will only affect the participating nodes. So as I said, a node contains data and a pointer. So that is your content of the node, you know. So let us try to come up with some structure. Okay. So let's start some hands-on programming. Let's open a file. So let me open a new brand new folder. Okay. So here we can create a new file called testlist.cpp. Now that's a file, but what we can do here is we can define some header file in order to define the template of the class linked list. Now we can call it number list because we will start with simple number list of numbers for the linked list. So this is a header file. It can contain, I mean, you can do this if define, I mean, the standard specification, this one, and then you can just start coding for the class. So your class can contain some instance variable, private instance variable, and now you can see the node. So the node contains some data. So in case of data, data is not a complex object here. It is a simple primitive variable, double variable, the value, and we can create a struct. Struct is a structure. You could create a class as well, but in order to make our life little easier, we build some struct around that. So that's your struct. So we define a structure named list node, and then this is, we have just one pointer, that is the next. So next is a struct, but here this list node is a pointer. Okay, So why we use the pointer? In order to point to the next node. So in C++, we are blessed with the presence of pointer. That's why we can point anything to anything. So that's what we are using here. Okay. So we created a struct. You can see here, this struct is the list node, and within the struct itself, we are referring to another struct because of the node structure of the node. As you can see in this picture, you have a data pointer. So your data is the value, pointer is the struct list node next. So now you can start with your linked list with a very primitive, I mean very simple head. Head is the head pointer. That means whenever you have a list like this, let's say you have something like this. So you have data, you have pointer. So in the top of the list, let us say the list is organized like this one. So what is in the top? Top node is called the head node. So that's why we define the head node inside our code. Like here, list node is head, and then we can define the public interface. First the constructor and then the accessor and mutator functions. So you can have a public constructor where head node is pointed to the null pointer. So why I'm doing this? Very simple reason. When there was nothing, we had the head node, right? And since there is nothing in the list, so head node cannot be pointed to anything. So that's why we set head to be equals null pointer. In C++, null pointer is, it means it's nothing, it's absent. Then we define the destructor as well. Then finally we have the operations like append node, insert node, delete node, and display list. So append node is basically appending one node. Then insert node is inserting one node in between the list node, deleting something from the list node, or you can show the elements of the linked list. So these are the available functions. And you can see that this is just a template of the class. I mean, it's not a, it's just the API or kind of API or template. So all the methods are abstracted here. There is no concrete implementation of any method here. So which we are going to do in any way. Okay. So for the linked list, let's build a C++ file that will basically implement the constructors and destructors and other member functions for the number list. So we can create another file and name it numberlist.cpp. Okay, so we can start adding the headers here. So we have used two headers, input output string and numberlist.h, the one we defined just now. So let's start with the append node, how we can define the append node. So it's little bit of longer implementation. So you can see here your so you can see here that you can append a node. So You can see another thing that this append node has a return type. It does not have any return type. It is a void, or it does not have any return type, not value returning function, because its function is to append a node to the next to the list node. So the structure wise, you can see you have new node. That's your uh, pointer to the new node, and then you have another pointer to move through the list. Now you can allocate a new node and starts from there. So you can see the new node, we are instantiating this class, this struct basically. Then we assign the value. So new node's value is the number that we have it here. Then next is the null pointer. That's how your new node looks like to begin with. Then you, if the head is not there, you can say head equals new node. Otherwise, you can do node pointer equals head. So the pointer is equal to head, and then you can find the last node in the list as by executing the while loop, and then you can insert the value as the last node like this one. Node pointer next is the new node. So that's how your append works. You have display. Display is pretty simple, iterating through the nodes and displaying them. So you can see here that we are iterating through the node and just finding the value of each pointer. You can also see, that your if the head is not defined, then you assign head to the new node and then you move on. If it is already defined, then you are basically swapping the things. You are just iterating through the list. So you have to, uh, like you write a ladder. It's the same thing. You have to go pointer by pointer, and then you have to go up until the last node arrives. So this is taken care of in your while statement here. Until your next, there is a next node, you keep on doing that, and that's how you can find everything there. So that's the append node, but then you have the display list. In the display list, you can run a while loop. So while loop, uh, as long as the node pointer exists, then you keep writing it on your console here, the display. So once the display is done, the current node is becomes the next node. So that we are just moving from one node to another node. So basically the walking is like this. We have this vertical list of nodes. So we are traveling from in this direction. So this node, it is pointed to the next node. And then once this node is, you make a, you touch that node, you complete the journey to that node, you say you are then pointed to the next node, and then after completing this journey you are going to the next node. That's how it is propagated. So you find out the list of the objects. So these are the bare minimum functions. So you can see we wrote append node and basically the display list here. Now, these are the two bare minimum functions we came up with. So let's say, So as a next step, we can write a driver program. So this one, test list. So here we start with the most, I mean the bare minimum stuff, that is this one, the header. Then you write the main function. Okay. So this is our main function. Oh, that's something wrong. Yeah, that's good now. So we define the number list object first. So define means we are creating a number list object. Just instantiate that. And then we can keep on appending stuff. So your node is now formed. The next step is to display. So we can say that list display list, then return 0. So if you just do that, then you can build the program. G++. So we should have a forward slash ahead of it so that it can be parsed. And then we have the program's name, that is number list.cpp, and of course the test. That's your test program or client, or you can say driver program. So what is going on here? G++ unrecognized. Oh, okay, that's the wrong thing. We should do it like, should not put dash, it should be dash O, then dot. And number list also should have a dot, I mean forward slash. This should have, is it the forward slash that we want? Let's see. So somehow I'm not able to delete that. Let me delete it. Okay, exe. So number list. So we can say this is the test list. Have some problem. So number list, it should be inside the, it's under the CPP file. So let's go to the, oh, there's something wrong here. No, no wrong. That's number list or CPP. So here's where we defined um, number list, this one. So we have the number list. Number list CPP contains that. And this guy also contains that. So what's the problem? So it says that list append node 2.5. So what is the list here? Number list is instantiated as list. That should be fine. But then number list was not defined. Line number 6. Why? I have already defined it, right? I mean, we have this number list. Let me see if we have done any spelling mistake, something like that. So number list, it should be there. Even more errors. Something is wrong, definitely. So if I recreate this one, so you have include included number list, and here you have the number list. So this dot h is there, number list dot cpp is also there. So what is the problem? So does it, oh, okay, I do see that um, your number list, it contains the number list dot h. It has number of undefined functions. So I don't know whether this is insert and delete, we don't have it here. So number list or CPP should define those, but it defines only the append node. Okay, did we save everything? Oh, we have not saved anything. So we have to save as save all. So that's a common one of the common problems. So now we have even more errors. So it says that undefined reference to number list. What is going on here? Did you forget to include, so 3 1, let's see, this should be under here. So you have the include functions for the number list. Let's revise it a little bit. So we have that one. So we have the number list defined here. Now let's try it. No. Oh, we define it? Test list. Did we make any? We did not make any spelling mistake. So what is the problem here? Undefined reference to number. Oh, I think we did not also define the destructor here. So there is a lot of incomplete implementation here. So we need to do that. So we have in the number list or CPP, we have, sorry, this one, we have only couple. I mean, we have only the display list and that one. But in principle, we have to define everything. So let's complete that. So we have one insert node, which can be defined as like this. So you have, let me maximize the window. So you have your append node, you have display node. Now you have insert node. So in the insert node, actually, we have, let's see. So you have this next node only, but why, how come it is containing the previous node? Let's see. Let's keep it. And then we also have the delete node. Let's define the delete node. Should be this one. So what's wrong in here? Qualified name is not allowed. So I think we made some mistake here. We have to include the curly brace. That should solve the problem. Yeah, that apparently solved the problem. So that is there. And then we should define the destructor as well. So that is your destructor. So what is going on here? You have the node pointer, you have to traverse to the list and point to the next node. So basically, if it is not null pointer, we are saving the pointer to the next node, and the delete the current node, otherwise it will accumulate dynamic memory. So that is about it. Let's try to rerun it again. Yeah, this time it worked. So list dot executable file. So what happened? It actually we need to call the display list. So we can do that. You have to align it in certain way. Oops, something wrong. This should look good. Then you have that, and then you can see that whatever we inserted, we could display. So that's the beauty of it. You could delete something as well. List delete node, you can say 7.9. So compiled it again, and if I run it, you can see that node has been deleted. So that's our elementary implementation of linked list. Let's give a break for 10 minutes and we'll be back and cover the remaining part of linked list. So we were talking about the node organization. Sorry. So it's like it contains 0 to more than 0 nodes. It has a list head to the point to the first node. The last node points to null. So you have this one. You can create an empty list if a list currently contains 0 nodes or there is no node in the list. So it's a very hypothetical situation. Then it is called the empty list. And in this case, the list head points to null. So you have this one. There is nothing in the list at all. You can declare a node in this way. That's what we have done. And no memory is allocated anywhere at this time. Then you define linked list. So it's the same way we did that. Let's say we have this one. So let me open up this. So as we defined here, you can see we define the struct node, the node, and then we define the linked list, the head pointer. Let's move on. So the head pointer is initialized to null pointer to begin with. this indicates an empty list. Then the null pointer used to indicate end of list. It should always be tested for before using a pointer, so you can do that. So you should say while f is not there, then you do something. That's how we can validate a null pointer. We say that it's if it is not null. Now there are multiple operations. That's what we showed: the append, insert, delete, and display. So append a node to the end of the list. That's what we did in our example. You have inserted a node within the list. You can traverse the linked list. You can delete a node. You can delete or destroy the list. So that's what we have done. I'm not going through the line by line code because we have already wrote it. Already we have written it. So it's like this, the way we wrote the code. So you have the .h file. This is your structure. This is the head pointer. Then you have the public constructor here. This is your destructor. And then of course you have append, insert, delete, and display. These are the main functions in the linked list class. And then we have implemented everything here. And finally we defined a client or the driver code, and then we applied it and it works. As we wrote the code, it works. That's our linked list. So when you create the new linked list, when you create the new node, you have to allocate some memory, right? Then you initialize the content of the node. You can say new node and then the value. This is the data equals the number. So that's what we have done in the very beginning. So let's see here. So that's what we have done it, you know. So that's how we are doing the insert node. Number num is the number that is inserted into it. Now you can also set the pointer field to the null pointer. You can say next is equals to null pointer. So that's how we define the first node, the head node. Then you append it, add a node to the end of the list. So you can create the new node. You can create the new node in this way, and then just add this node at the end of the list. So if the list is empty, set the head pointer to this node. If the node is not empty, then traverse the list to the end and set pointer of the last node to point to the new node. So it was done in here. So let's say what happened. So append node, you can see here, it's pretty simple here. So you have list node, that's the new node and the node pointer. Then you say you allocate a new node and store the number here. So here. Now, if the new node is if head is not there, then you make the head as the new node. Otherwise, you can just you can define the pointer to the head, and then you can just organize the stuff. You can add it to the end of the node. So now at this point you have a head node and another node. That's how you form a you append a node. So here, so you have a list that is the head. So what you do here, you have this list to begin with, then you just add it to there. So here the node pointer is here, and then you have the new node. So new node, this is then pointed to the new node, and new node pointer is pointed to the null. So end of the node. So you have added to the end of the list. So basically you have this one. So from 19 you have pointer to this one, and then this one, the pointer to 23 should be null. because nothing after there is nothing after this particular node. So inserting a node into a linked list, it used to maintain a linked list in order. It requires two pointer to traverse the list, the pointer to locate the node with the data value greater than that of the node to be inserted, and then the pointer to trail behind one node to point to the node before the point of insertion. Now, the new node is inserted between the nodes pointed at by these pointers. So you do it in this way. So here is the deal, that your new node is here. So this is your node in the previous state. So after 19 there was nothing. So you create a new node just like that. So basically you create the struct and your pointer is pointed to null to begin with. Then you just what you did here is basically you have 5, 13, and then you compare what is the value of uh, the, I mean 18 is next to 13 in terms of the values. It's a sorted, let us say. So your pointer is pointed to the 18, and then pointer to the 18 should be pointed to 19, that is the highest value, and the 19, this pointer should go to point to the null. So that is the end of the node. That's your insert node. So when how you traverse the list, so you basically visit each node in a linked list. So you display contents, validate data, etc. So basic process is set a pointer to the contents of the head pointer. While the pointer is not a null pointer, process the data, and then you go to the next node by setting the pointer to the next pointer. And then until there is a next pointer, keep doing the same thing. So that way each step you will have the current pointer, current node, and you display the data of the current node, and at the end you won't have anything, so you will finish listing the node. So this is in picture, this is displayed in this way. You can delete a node, it used to, I mean, you can remove a node from the linked list. If the list uses the dynamic memory, then delete node from the memory. It requires two pointers, one to locate the node to be deleted, and another to point to the node before the node to be deleted. So you have this one. So let's see the code that we wrote here, that is easier to understand. So you have two pointers to traverse the list and a pointer to the previous node. So these are the two pointers. Then if the list is empty, then you don't have to do anything. It is already deleted. You cannot do anything else. But if the first node is the one, then you can do, if the value is equal to number. So this was you were deleting. So if the first node is the one you are deleting, then you can do node pointer is to the next, and you can delete the head, and your head becomes the next node. So you have head and the next node. So your head is deleted, so next node becomes the head. It's just simple. Otherwise, you can assign node pointer to the head, and then you move forward. So then you try to you iterate until you find a point where node pointer becomes null, or node pointer value equals null. I mean number, whatever number you are deleting. So you can keep on iterating, and then otherwise, I mean, if you find the node pointer, then you can simply adjust it. I mean, the previous node next equals the node pointer next, and then you delete the node pointer. So that's how you delete a node from here. And then you have a destructor defined in this way. The destructor is simply to clean up. clean everything up. So you can see we have deleted the dynamic allocation of the memory. Um, Pay attention to the destructor a little bit. When you write a linked list, you must have a destructor as well. So we deleted this one. So destroying a list, basically you must remove all nodes used in the in the list. To do this, use the list traversal to visit each node. For each node, you need to unlink the node from the list. If the list uses dynamic memory, then free the node's memory. Set the list head to the null pointer. Those are the steps. Now we can define the linked list as the template. you know so the template version is very interesting. So what you can do there is basically you can define it as a template. So let's do a little bit coding around that. So create a new folder here. So basically under here, create a new folder named let's say template. Under the folder, let's create a file called, first of all, let's create a file called linklist.h. So this is the one. So a class template to hold the linked list, we can define. Let's do it in this way. So the headers first, then we can say the template. So usually the template is defined in this way, and then we can define the private uh, instance variable, just like you have done before the instance variables, but you have to make a consideration for the inside it. There is nothing changed. You are just making it the linked list of any arbitrary variable. It's not the double. In the previous case, we create a linked list of the double variable. In this case, we are doing it for any template. So here we can do this. I mean, there is nothing changed here. We just replaced double with the t. T is any arbitrary object. Now we can just do the essential methods implemented. I mean the append node, these methods, insert node, delete node, and display list. So it's simple because you are not changing anything. So for the append node, you are just using the same append node almost, but you are using the template, instead of the concrete uh, like concrete numerical variable, concrete primitive variable. You are using the template t. That's all. That's all you are doing. Everything else remains exactly the same. So this one is exactly like the previous one, but it's more generic. Now let's have an implementation of that. Let's say we are doing some foot inches. I mean those measurement object. So let's create a feet inches object here. That's a measurement kind of thing. So this is the general linked list. Now we are doing a specific one, feet inches dot h. So you are creating a measuring software. So basically you say you are overloading this operator, the stream operator, output stream and input stream operator. And then you can say the so what we are doing here, we are creating some number. So number of feet and number of inches. So we define we simplify. So we can simplify it to define to express it in number of feet and number of inches. So those are the essential operator functions. You can see I'm going to include this code in the as a inside the files of your canvas, so that you can also go through it whenever you get time. So these are the essential functions here. And then we can create the concrete class for feet inches, that is, I mean, implementation of the feet inches. So we can say we can create another file named feetinches.cpp. So there we can just include all the definitions just like this. So we are just defining the number of, I mean, this simplify. You can note here that if the inches is greater than 12, then you are expressing it in terms of feet, how many feet is there and how many inches is there. That's the simplify. So if you have 13 feet, you will express it as 12 feet. So it's a feet inches, it's it's represented as 12 feet and 1 inches. So it's something like that. So you will find out, you will be given a number. So if the number is 15, then you divide it into how many feet are there, how many inches are there. So 15, if you have 15 inches, that means you have 1 feet and 3 inches. That's how you're representing it. So we are done with that, and then we can, sorry, we can create a driver program. So we can say driver.cpp, and your driver program could be simple as this one. So you have input output stream, you have the header, you have the feet inches.h, and then you just append some nodes. Then you display the list. I mean, you are doing all the operations inside this code. Then you can do save all, and then just go to um, template. So G++ feet inches.exe, and then we can refer to the C++ files, that is your feet inches.cpp and driver.cpp. Those are the main important C++ files you have. So now we can execute the code. So you can see here, initial values 5 feet 4 inches, inserted value in 7 feet 2 inches. So you have the other nodes now. So basically these are the nodes. Now you are inserting different nodes in order. So you have different measurement values. So that's how this class is formed. So let's move on. So we have the variations of the linked list, other linked list organization. You can have a doubly linked list. In this case, you have a previous node and next node. Along with the previous node, you will also have the next node also. So the the standard template list and the forward list containers, I mean, these are the standard containers. I mean, you can just go through the book and get some information about that. There is nothing to implement here. It is already implemented for you. You have to just use it. 18.5 is not that important. Main important thing in this chapter is defining a node, then you define a linked list, and also use the template. That is what you have to do. So we have learned three main things in this chapter. Number one is, I'm just using this slide to write the summary. So we have defined the concept of linked list. Then we have some implementation. Direct implementation means we have a simple linked list. But then number three was the template. So template is important because, you know, when you use template, then you can use anything to define your linked list. So these are the main thing that we have learned. Let me do it in a more concrete way, because this writing you cannot read at all. So let's, if we do it in this way, we learn three things. Number one is what is linked list. Number two is simple implementation. So we have implemented a number list. And number three is the template, how we can use generalize the simple implementation by using the templates. Those are the basic things that we have learned in this class today. So what I'm going to do, I'm going to attach these C++ files in your